Test 1, 2, 3. I think we should be live. Let me see. Yeah, I think everything is okay. My audio seems to be working. Seems fine. Okay. No idea if anyone's watching, but nice evening, everyone. I figured I'd do another live stream. It's been a while since I've done the first live stream on the channel, and I thought it was kind of cool. So yeah, let's do it again. I have here a patient on the workbench. It's a chassis of a monitor. So the idea is to do a bit of solder and chat. So go over it and then yeah, do the recap and everything. So I think that's not really super interesting to make a dedicated video out of, so I thought, well, live stream might be more fun to do. Now I noticed here that there is here a wire that came loose here from this side. Wait, I need to switch screens so that I see what I'm doing. Just a second. I just noticed that there is a wire here that came loose, so I would have to reattach that. This is the chassis that came out of my arcade cabinet. So I have an arcade cabinet with a CRT monitor, obviously. And wait, I'm just gonna put the chat here on the screen so that I can follow easily. Just give me a moment. Okay. So I have an arcade machine, and the monitor needs work. I think the tube itself is still okay, but I can't always get the picture locked in place. So sometimes it just keeps rolling. I cannot adjust the monitor in such a way that the picture stays stable. There is a bit of deflection on the picture at some point. So it needs a bit of work, and I can't really do any work on this before I recapped it, because I think it really needs a recap. Now usually equipment from the 1980s doesn't really need a recap, but in this case it's an arcade machine. It has probably been running for, I don't know, maybe thousands of hours in very difficult environments, like hot environments and things like that. So I think a recap is gonna help. And I already cleaned the PCB as much as I could without causing too much harm. And yeah, because it was really dirty. It was completely covered with black, yeah, I don't know, dust and everything. So yeah, it should be okay to work on. I found a service manual, and I also found someone who made a sort of overview on all the things that you should do when you are recapping or when you are working on this thing. Let me see if I can pull it up. Just a second. I think it's this button. That should be it. Yeah. So this is the service manual. It is, well, quite extensive, even though I don't think it matches completely. Well, maybe it does. There are some different revisions between the boards, I noticed. So it is a Hantarex monitor, MTC 900E, I guess, because the sticker is gone. Normally there should be a sticker here on this side of the chassis. That's gone, so I don't know the exact model number, but I think this is really close what is here on the screen. So yeah, I think that's it, but I'm not completely sure. There are some variations in this monitor. This probably was an extremely popular arcade monitor in the 80s, so there are some variations. Now, someone has written this. So yeah, like the Hantarex MTC 900E wellness guide, where basically well, explains what you need to do. The list of all the capacitors, it's 33 items in total, 33 caps in total, so I don't know if I will be able to finish that today, but well, we'll see how far we get. And here is the instructions to disassemble. Here the guy actually marked the places of the caps on the board. Here second PCB as well, and third PCB, same thing. So yeah, this way I can keep track of what I'm doing, more or less. So I think that should be fine. Yeah. Now my microphone is a bit stuck. Just a sec. Bum 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 bum. Right, so I'm just gonna turn on my solder iron and let's see if we can get going. So normally I should have all the values, all the correct values of all the caps. I placed an order on DigiKey a while ago with the missing values. There are some weird values in here, less common values which I didn't have. So I normally should have all the caps that I need. Now this thing consists basically out of 3 PCBs. So this is the neck board, obviously, and then the chassis here, that's 2 PCBs. So see, here is a divider basically. So this is one PCB and this is one PCB, and there are some wires, some jumper wires to connect both of them together. So that's why in this service manual we saw 3 different PCB. But yeah, as you can see, there's quite a lot of them, and especially the small ones I think will be very much out of tolerance, I assume. This is gonna be a bit of a juggling act to keep it on its side while I'm working on this. So this is the back, in case you are interested. See, here you can also see this is the divider. These are 2 separate PCBs. Now, unfortunately, as this is the chassis of a CRT, I will not be able to test it on video afterwards, if it has helped or if it worked or if I didn't damage anything, because, well, my arcade machine is upstairs, and I don't want to reinstall this in the machine while doing the live stream or doing a video. I just really want to concentrate on doing that because it is not the safest type of equipment, right? There is high voltage on there, so you really need to pay attention to what you're doing. So this stream, I'm only going to do the recap, and then we will, I will test it afterwards, and I will show a video on the result on the channel probably. Okay. Now this thing, as I said, it did work. There is the one Achilles heel that this PCB has is this transformer over here. That one dies often. If you have a monitor like this and you don't have any high voltage anymore, suspect this transformer. There are some extremely fine wires, and sometimes they corrode and they break, and then the transformer goes open and high voltage is gone. You can repair it, but this is a very common fault on this type of monitor. Now mine doesn't have it. Mine is still fine for now. So just gonna do the recap. I don't know if the recap will fix my problems. I hope it will, but at least I can't be sure that it's something else before I've done the recap. Because everyone's saying online, when I search for this on the interwebs, that I see a lot of comments of people saying that this thing just should be recapped, and that's basically it. Now let me check if everything is still healthy with the stream, because I am still a beginner in all this streaming nonsense, so forgive me about that. It should be okay, I guess. I think the stream is indeed running. And yeah, everything seems fine. Okay, this one is hot at the moment, so I think we can start. If you want to have a chat or if you want to ask some questions, just post them in the chat, and that's a bit the point of the video, right? So, I think maybe I'll start here, this section first, or do I do the neckboard first? On the neckboard there's not a lot to do. There is only one capacitor on there, I think. I know there is another one here beneath the high voltage cable. Yeah, I see two. Let's do the neckboard first. So we have here 4.7 microfarad at 250 volts. See, that's already something that you don't have in stock by default. And then we have here on this side, I can't read it. It's 10 microfarad at 50 volts. Yeah, 10 microfarad at 50 volts. Let's do that one first. 10 microfarad. Okay. Is it marked correctly on the board? Yes, it is. That's what I always do before removing a cap, seeing is the polarity marked on the board, and if it is marked on the board, is it correctly marked on the board? Because yeah, you never know. I've had some surprises in that sense. So this is C50. Oh, this solder melts really well. So that is promising. Pum, pum, pum. And yeah, that one is out, and indeed it is a 10 microfarad at 50 volts. I don't have a desoldering station, so things will have to be done manually. So I usually just take the worst part out of it with this pump, and then I just clean it up with some solder wick. Yeah, hello Kaspars, and for some reason my chat is automatically translating to Dutch. I don't want this. How do I... hello from UK. Yeah, hello to you too. For some reason my chat is automatically translating to Dutch, which is incredibly annoying. I wish that YouTube would stop doing this kind of crap by automatically translating stuff, and I don't know how to turn it off. Anyway. Anyway, I'll have to look into that later. Wow, everything is in Dutch in the chat. This is really, really bad. This is really something that I would like to... How the hell do I... wait, let me just Google this. Because that's not... everything that you guys are saying now is in my is in Dutch, and I really don't want that. To disable automatic live chat translators in YouTube. Stream settings. Right. Where the hell is this? On desktop PC live, go to YouTube to navigate to the live control room. Okay, click on the stream settings tab. Is it? Nope. I have no clue where they put this setting to disable this crap. Anyway. I will react to your chat messages in a second. I'm just trying to figure this out. This is... So they say here, go to the live control room on the stream settings tab, locate the video detail box and click edit customization, then untick the live chat translation. Where the hell? Anyway, I think I'll have to figure this out offline. After the stream, I'll just have to hover over every chat message manually to see the original chat message. So this really is bad. Anyway, Colin. Hi Colin, from a field in Lincoln, UK, walking our 3 dogs and being chased by a lot of mosquitoes. Oh, did the mosquito season already started? Here I don't think we have lots of mosquitoes yet. I haven't seen any in any case. Hi Petronics. Was this a question to me? Where did you learn electronics? Just by doing it myself as a hobby. I started doing electronics as a hobby, I don't know, maybe 15 years ago. I actually started with things like this. Well, not really CRTs, but I started with pinball machines and the arcade PCBs, not monitors, but the electronics on arcade machines. And then I just, well, used internet to learn everything, basically. And then after a while, I moved into vintage audio gear and tube radios and things like that. And I really stopped working on all the arcade and the pinball stuff. But I am trying to pick that up again a bit more recently, because I did like working on those things. The only problem is that they take up a lot of space, and it's not that easy to make a video about like a pinball machine, because you have to, well, it's huge, so you have to set up the camera, you cannot really work on a desk, everything has to be done inside the cabinet, so it's not that easy. Working on the radio is a bit more easy. So that's why. So what did we have here? I already forgot. 50 volt, 10 microfarads. What do I have in 10 microfarads? 10 microfarads. This is 50 volt, I guess. Yeah. 50 volt, 10 microfarads. And yeah, this is maybe, I don't know if you can see this, but it's a bit awkward to work on this neck board. That's why I'm doing this first. And the positive on this side. Okay. It's the first time that I'm using this solder. I picked up a new roll of solder on DigiKey because I ran out of leaded solder, so I picked up some chip quick. So far it seems fine. Let's actually see if this cap is still okay, or well, how bad it is. Just let me grab my tester. I think I put it somewhere. Yeah, here it is. Let's see what we can expect from these caps. I think they're gonna be bad because yeah, these are in a very, very intense application, and these are they rated for temperature? Yeah, they are 105-degree caps, but I think they're gonna be pretty cooked. So this is 10 microfarad. Let's see. Whoa, look at that! Well, I don't think if we would have done a capacitor bingo that you would have guessed this one, right? So this is a 10 microfarad. We are at 3.83 microfarad and an ESR of, yeah, outside the range of the meter. So yeah, they are baked. So you see, it's really necessary to recap these. It's a miracle that it actually still worked. If all the caps are going to be like this, then yeah, it's really needed. Okay, we have some. Let me catch up with the chat. It's really warm here, thanks to mosquitoes from the nearby water. Ah, okay. So it's not yet warm here. They do predict some nice weather for the coming days, but at the moment it's not yet super warm here. That's real to do. I just want a 7, but never. Yeah, that was passionate about it, but the knowledge is here. Yeah, for me it was actually the other way around. Basically, I was always scared to break something. So when I was a kid, so I didn't. I was curious how things worked, but I didn't dare to open things up because I was always scared to break things, to break my stuff. Now, I heard from a lot of people in the electronics hobby that they spent basically all their childhood opening stuff up and looking inside how things worked, but I wasn't like that. And then Petronics, I broke my parents' Roberts radio when I was about 10. They were not pleased as we had nothing else for entertainment. Yeah, I can imagine. Next one. So this is the 4.7 microfarad, 250 volts. I think I had to order this one in because 250 volt caps, I don't have them. Yeah, here they are. I don't have all the 250 volt caps just so in my stock. I usually only stock low voltage caps. So this is 4.7 at 250. So I don't know if we'll be able to finish this thing. I don't think so, honestly, today, because I do have a, well, don't want to go to bed too late. So we'll see how far we can get. Oh wait, the polarity. Oh, this one is, the negative is marked on this side and the positive is marked on the PCB. Yeah, that's fine. Okay. I think it's already out. No, not completely. Okay. Now, to be fair, to come back on the question, where did you learn electronics? I had some electronics at school. I studied engineering and we had an electronics course, but this was extremely theoretical. There was not practical at all. So and it was an extremely difficult course as well. I remember everybody had difficulties with this course, and it was only, well, not even a main one. It was like a smaller one, but it was one of the most difficult courses that we had that year, and it was super theoretical. It was basically a maths class. That's not really electronics, and so yeah, that I didn't really have any formal education in electronics except from this pure theoretical stuff. So nothing practical. To give you an idea, so we had it one semester, and it was super difficult, and everybody was a bit scared of the exams because they were, yeah, known to be easy to fail, and the professor was also very strict, so it was really a difficult course. And I think I studied a lot for it, quite a lot to get through, and I think in the end of the semester, if you would have asked me what is the difference between a resistor and a capacitor, I don't think I would have been able to answer. So that is the level of, yeah, how theorized everything was. It was just basically maths. It was not really electronics. Hi Timothy, nice evening to you. I think this one will be also probably cooked. Let's put the new one in. This is even only an 85-degree cap, so 4.7 microfarad, 250 volts. And this one, 4.7 microfarad, 250 volts, yep. Now, I am not going to clean this. See, you can still see it's quite dirty. I will not clean this up in, yeah, to be so that it is completely pristine, because that would be so much work. I'm just gonna make sure that it runs again. So plus is on this side. Okay. That one is in. And I think then the neck board is already done, because I think there are only 2 caps on this one. We double check. Quite a lot of resistors and lots of transistors, but only 2 capacitors. So let's test this one. So this should be a 4.7 microfarad at 250 volts. Yeah, that's better, but an ESR of 2.1 ohms for a 250 volt cap, that's probably also too high, I think. And it's, well, 4.7, 5.3. It's not that it's that's completely shot as the previous one, but it's also tired. Only things we had to learn at school was how to connect a battery to a bulb and put switches in between, and most of my classmates didn't know how to do. Yeah, I can imagine. It always, especially when I was in secondary school, we had some really basic informatics, like just Word, Excel, Windows, things like that. And so the tests that we then had to do was like, you have to copy a file from a folder to another folder, and then you have to rename a file, and so extremely basic computer stuff. And there were still people that managed to fail those tests. I never understood how they did it. Okay, now let's start the big one. Well, the big one, this is basically the big one, but that's the one that has the most caps. So, and lots of small ones, so maybe we can start with that. I'm just going to start here in the top right corner, and we're going to work our way through this. And if I already finish this one today, I think I'm going to be happy, because yeah, it's littered with tiny capacitors. And I think these are all gonna be bad, because that really bad one is an ITT cap. It's also a small one, and these are all the same brand. So I expect total carnage here. Are these marked correctly? I think so, yeah. This one plus is also marked on the top. So let's get that one out. Can't really see the value from here. Oh yeah, I can. It's a 47 microfarad at 25 volts. Okay, let's get it out. Yeah, I hope so too, Colin. And I think it will, because I think the tube is still really good. Well, the tube still looks very bright. It's just the fact that it is, the image is bending, and I cannot get it to lock in, to sync correctly and things like this. So I'm just gonna put that one here on this side, and let's, no. It's a 19-inch CRT, by the way. It's not the largest of CRTs, but you're really close to the screen, so it's fine. Okay. Now let's see. This was the one that came out. 25 volts, 47 microfarad. 47 microfarad. And let's see how this measures. Yeah, these caps, they are all gonna be completely shot. It's ridiculous. I don't understand how this thing can still work if all those caps are shot. It's completely ridiculous. 47 microfarad at 25 volts. Let's see, what do we have? This is a 47 at 35. I think these are 25. Yeah, I'm gonna set this container over here, because I think there are quite a lots of caps on there which are this value. So positive on top, like this. Just have to make sure that I don't break anything, because there are some coils and like transformers on here, so I don't think anything, well, the wires of the flyback, they stick out, so I'm going to, maybe I should do it like this. Okay. I can't imagine that I actually, well, I did manage to get the picture into sync at some point, but then I had to shrink the picture drastically. It didn't fill up the entire monitor. Then I could get it into focus and into, well, sync, and then I actually used the machine and I played with the machine for quite a while. Cannot imagine that this actually worked if all the caps in here are completely shot. Next one, it's C83, and it's also marked correctly, so the positive is here towards me. Okay, let's get it out. hits. And this one is, can't read it. It's a 105 here, 47 at 25 volts, so it's the same one as before. Bum, 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 bum. Yeah, see you later, Colin. Thanks for dropping by. Let's see how shot this one is, because this is really, it's quite funny. Um, 47, should be 47. That it is just so out that the tester can't even read them. It's just, yeah. And the positive on that side, okay. Yeah, any time you are working on yeah, amusement machines like pinball machines or arcade machines or slot machines, then you encounter all kinds of issues that you never encounter normally on consumer equipment, and these are obviously due to the fact that these machines have had an extremely rough life. They are almost all the time extremely high hour machines. There is a lot of heat and vibration in these machines, so things like this are normal. Next one, C36. It is a 22 microfarad at 35 volts. So 22. 22 microfarad. This is 50 volts. This is 15 microfarad. That's 63 volts. I think 50 volts is the closest that I'm gonna have. Let me check. 400 volts. 250. $100 volts. Now these are all higher voltages. The ones that I ordered in recently, they are all higher voltages. So let's first take this one out. The plus is, wait, on the far side. Okay, here on the top it's the negative. Okay, and let's take it out. Wait, which one is it there? That one. It was almost desoldering the cap that I just put in. There it is. Yeah, it's difficult to show you both sides of the PCB while I'm doing this. I'm not doing anything spectacular than just cleaning up the solder here with my solder wick, and then we'll put the new cap in. And wait, what was this again? 222. It's an Elna. 22 at 35 volts. That will become a Wait, this is the 47 box. That will become a 22 at 50 volts. And the negative was here on the top side. Like that. Okay. Now let's test. This one, I'm curious if this one will also be that bad, because it's a different brand. It's an Elna, and no, it's a black one. I thought for a second it was a dark green one, but it's a black one. Let's see, so this should be 22. Hello? Wait, what is... Not detecting anything. What is happening? Is my tester okay? I guess it is. Wait, what? Yeah, this is when I touch the leads of the tester, okay. This is just... It's not detecting anything. I haven't had... That's the first time in my life, I think, with this tester I encountered the thing that it's totally open. There is absolutely nothing in there. What is happening? This is really real carnage, these caps. Wow, impressive. How the hell does this thing still work? That's completely ridiculous. Next. Now we have all these small ones over here, like there you see there's an entire row over there, and there's another row over there. So these blue guys, they are all, and I can't read it. Ah, it's on that side. 10 microfarad at 50 volts, and they are all with the negative here towards the top side of the board. So let's take out the first one. Now I need to find the correct spot, and I think it's that. Or not. No, it isn't. It's that one, but yeah, that's the one. Okay. Timothy says the lead is not connected to the foil inside, I guess. Yeah, probably. But then, yeah, probably. Let's check these blue guys. So as I said, 10 microfarad at 50 volts. Ah, that is slightly better. These are still fine. Well, 1.88, I think that's still fine, but it's also creeping up, as you see. But this is the first cap that is still acceptable. So 10 microfarad at, what did I say, 40 volts. So then we need to go here, and I'm gonna put a 10 microfarad at 50 volts. Now let's see what the ESR is on this new cap. The old one was 1.88 and the new one is 0.95, so it's half the ESR. So negative on the towards the top of the PCB. I'll put it in, but I'm not soldering it yet. I'm just going to take the other two out as well. Just to speed things up a bit. And then the next one is over there. My microphone just keeps on trying to fall down. Super annoying. I think I did something wrong. Just one moment. I think I did something wrong here with the microphone. Yeah, that's better. Let's clean up the old solder like this. Okay, and that one as well. Okay. And I think, well, if that first one was okay, then I think these two should also be fine, because they are identical. They are also 10 microfarad at 40 volts and same manufacturer. So this one is, yeah, okay, that's still fine, I guess. And this one, also still okay. Let's put the two new ones in. What is that was a ground plane, so I was wondering why doesn't this solder, but yeah, there was a ground plane that took quite a bit of heat away from the pad. Okay. Now this one. Yeah. Okay, next. Now there is a row here. The next row, there are, let me bring this in a bit closer. I don't know if you can, but this next row is, well, 3 black and 3 blue ones that are interleaved. So yeah, the black ones are 4.7 microfarad at 63 volts, I think. The other ones are 15 microfarad at 16 volts. Let me quickly check that on the drawing, because I can't really read it very well. And it's not indeed, it's not on the drawing. They are interleaved here as well. So, yeah, so wait, let me share the screen here for a second. I think it's this button, yeah. So here we are talking about, I think, C19 or 18, 19, 20, and then 27, 29, and 39. But they are here in this PCB, they're not in a row. On my PCB, they are in one row. So 19, 20, see, they are 4.7 at 16 volts. Is that the same that I just said? No. No, it's not the same thing. They are not the same. So yeah, so this PCB is different. It's clearly different than what I have. I'm looking for sorry, I bumped my microphone. I'm looking for 15 microfarads, and I cannot see that on here. No. So, I think I'm using the wrong guide. This is here the service manual. And yeah, the caps are not really labeled here. Same thing here as well. I think, oh no, these are labeled. Yeah, here this is the same. Here you have also these 6 caps in a row. See, it's 18, 19, 20, 27, 29, and 39. So the numbers are the same. But the values... wait, so this is on the PE interface board. It's 18, 19, 20, 4.7 microfarad at 16 volt. They are not that here, they are 4.7 microfarad at 63 volt here on my specimen. And the other ones, same. So that's weird. These values are different than what is installed in my my unit. Anyway, I'm simply gonna replace them by the ones that are installed, the same values that are installed. And they are the black ones are with the negative side down, pointing down. So let's take one of these out. Here it's labeled C27. Huh. So then they are, it's weird. See, I think there are multiple different, yeah, C27 on the board as well, yeah, 10 microfarads. See, and the other ones, they are 4.7, no, they are 50. Now, see, I think there are different revisions of this PCB, and the values, they are slightly different. So let's take this one out, C27. With the negative side down, and it's indeed a 4.7 microfarad at 63 volts, and it's a Nippon Chemicon, so again a different brand. So I think we already had 4 brands of caps in here. I have ITT, Elna, this is Nippon Chemicon, and I had another one as well. This big one was also Nippon Chemicon, so 3 different brands. So what did I say? 4.7. Yeah, 3.6, it's cooked as well. $4.7. at 63 volts. I don't have those. I have 50 volts, but not 63. That's a bummer. Did I, wait, let's see if I bought 100 volt ones for this instead of 63. What's this? That's not it. 330, here they are. 4.7 microfarad at 100 volts. So that's what we're gonna put in. So this can go back. Yeah. And the negative pointing down. I'm gonna take the other two out as well, and we're gonna do all three at once, just like before. And there is the third one. Okay. Let's test these two as well. .7, right? Yeah, these are all, yeah, 4.7. 3.8, so yeah, it's also low. And this one. 3.9, also low. They are not as dramatic as those ITT caps, but they are bad. Do. Yeah. .7 at 100 volt. And of course all the caps that I'm putting in, they are all 105 degree caps, and they are all decent brands, most of them Rubicon. I think all of them are Rubicon. I usually buy Rubicon caps. Positive on the top side, this one as well. Okay. I did also notice a new feature here on YouTube, is that it can automatically generate a vertical stream out of so I am streaming horizontally now, obviously, but it can also, you can just enable an automatic vertical stream as well. So if someone is then watching on his phone on the YouTube Shorts, then you can see the screen in a vertical orientation as well. It does do some really serious cropping. So if you are watching on the vertical and you're only seeing, you don't see me, basically you only see like the center of the screen, then just pop over to the horizontal stream because I think you'll have a better experience over there. And also don't forget to like the live stream while you're watching, because that always helps if you have people that are liking the stream. Next were these blue guys. They look very suspiciously like Philips caps, and I'm not sure actually. Yeah, they are marked Philips. So those are these typical blue caps that you encounter quite a lot in old Philips equipment. It's weird that they have these caps in there, but okay, it is what it is. And it's 15 microfarad, weird values as well. And the negative, well, these are axial caps that are folded over. And the negative side is, yeah, which one is the negative? I think the negative one is the one here, so like more towards me. Not really marked, or I can't really see the marking. Ah yeah, there is the marking. The marking is underneath the capacitor. Okay, so the negative side is indeed towards me. Let's remove one of those guys and see if these are bad. I think, are these soldered in manually? No, I think they are also original. Yeah. Well, I'm not completely convinced if these are originals, but okay. I do have the impression that they have a bit more solder on the pads than the other ones, so they might be like a very old repair or something, I don't know. So again, the point of the video is just a bit of solder and chat. So if you want to chat, so just put your question in the chat and I will try to respond as good as I can. This is, okay. I thought there was still solder in that hole, but it wasn't. So I was just cleaning up something that wasn't there. Now, these guys, they are also notorious for being bad in like audio equipment, these blue axial tiny Philips caps. 15 microfarad at 16 volts. Let's hook it up to the tester. Not 19, yeah, so that is almost like 30% high, I guess, so these are also bad. Now, 15 microfarad, I do have 15 microfarad caps, but not a lot of different values, so I hope, wait, where are they? Here are some 15 microfarad. Yeah, I have 15 microfarad at 50 volts instead of 16 volts. So 15 microfarad is already a value that you're not going to find a lot these days. So I don't stock 15 microfarad in all different kinds of voltages. And I don't think you could even still get like 15 microfarad at 16 volts. So it's going to be 15 microfarad at 50 volts. And these are Nishikons. And the positive side on the right, okay. And I'm going to take the other two out as well. If I can reach them, because there are lots of wires in the way. Yeah. They do have more solder on the pads than the other caps. So it is either a, it's getting hot because it's an axial one. And the lead that sticks out on top is getting hot. Jesus. Come on. Oh, super hot. Now this is either an old repair or maybe these were soldered in after the fact. Maybe it could be that sometimes these manufacturers during production they ran out of a certain type of capacitor and then they just didn't solder it in, and then when they had the right acceptable capacitors, they soldered then the correct value in place. So maybe these were soldered after the fact. Difficult to say, of course. Yeah, that one is out as well. But knowing that these are different values than on the schematic, maybe it's like a mod or something. No idea. I would have to check what these guys do in the circuit, but I'm not an expert on CRT electronics, so would take me a while to figure it out, I think. But since there are 3 of them which are what is wrong with my... Since there are 3 of them which are identical, it wouldn't surprise me it's like in the color information or something like that for 3 channels of color. Okay, there's really a lot of solder on these guys. Timothy says I'd have to put in a 22 microfarad if I was doing this. I know I don't have 50. Yes, I actually bought at some point a section, some 15. At some point I ordered some weird values. So I did, one time I placed an order, I included from weird values or less common values, I included like one, average voltage. So I have, for example, I have in stock, which are weird ones, is 6.8, 68, 82, 150, and 680. So that's about it, I think. So I had the 15 microfarad ones laying around. It really surprises me a bit that the values that got standardized for capacitors, they have quite a huge gap at certain points. So you have, for example, you have like, let's say, what example can I take? Like, for example, you have 100 microfarad, then the next common one is 220, then the next common one is 330, then the next one is 470, but then the next one is 1000. I mean, the usual suspects in between, which are then 680 and 820, those values, they became basically obsolete almost. So you always have a very big gap after the 470 or the 47 or the 4.7. And in fact, it's also the case between like 100 and 220 as well. It's more than double the capacitance. So the 150, yeah, I did stock them in at some point because I think I was working on the Philips amplifier that had a lot of 15 microfarad and 150 microfarad caps, so I ordered a bunch of those at that time. But then obviously I don't have a lot of variety in voltages. I only have the 50 volts. Okay, these are in. Yeah, I find the standard values they are out. The other thing is when you buy resistors, they have yes indeed. When you buy like a kit of resistors, you have like a whole bunch of resistors which are very well values that you will never use. But capacitors, nope. And if you go into more modern equipment, if you're repairing modern stuff, then it's even more extreme, because I've already worked on stuff that is, for example, there are only like 47 microfarad capacitors inside, and 407 and 47, and that's it. So it seemed like the more exact or the more specific values, they went out of fashion. Now let's test these other two that came out. As I said, 15 microfarad. I also expect them to behave the same, because I guess indeed this is in the color circuit, so that means you have a part of the circuit for red, green and blue, and then obviously they behave in exactly the same way, these three caps. They get the same amount of work. See, 18.8, it's very similar to the previous one. And this guy probably also the same. Oh! What happened here? Maybe I made a bad connection, or? Yeah, that one is bad. See, it's 2.66 instead of 15. That's peculiar. It's very weird. Anyway. Okay, humming quite along. We are now at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 done out of the 33. The next row. What's this? It's again 10 microfarad at 40 volts. So it's the same ones as we already removed. And the negative side is towards my left, and they are marked correctly, so I'm just gonna take them out. Wait, is it over here perhaps? Yes. Let's measure that one. If I remember correctly, the 10 microfarad ones, they were still okay-ish. I don't recall. Yeah, those were the better ones that we encountered so far. These are branded ADI. Never heard of those. They are only 85 degrees, and the ones that were completely shot, those were 105 degrees. So that goes to show it's not the temperature rating is not always the only factor, right? So wait, this was 10 microfarad at 40 volts. Where are my 10 ones? Here, this one is. These are 10 at 50, yeah. And the negative side towards me. Okay, and then let's take out the other two. Yeah, Caspers, you're right. I also like, that's one of the reasons why I like working on old stuff, because, well, to be fair, we have to be fair, it's not always good quality what is made, but what I do like indeed is that it's repairable, because yeah, you have service manuals, you have schematics, components are not so tiny that you have to uh, use a magnifying glass to see everything what you're doing. So they are repairable. Then not everything is of the highest quality, but since we like working on the more expensive stuff, well, things that used to be expensive, you often are working on high quality devices. And especially if you go into this area with arcade machines and pinball machines, those things were really built to last. So yeah, that is really professional grade almost in terms of quality sometimes. Like this board, for example, it is quite a bit higher quality than an average CRT TV from the 1990s, for example, right? So it depends a bit what you're working on. They really also, in the past, they did cut corners, they did do bad designs and cheap designs as well. But often there was also still really good quality. Yeah, Timothy, I understand why you. I like actually working with SMD components, but I can perfectly understand why a lot of people don't like it. I also hated working with SMD until I switched to using solder paste, and now I really like it. It's almost like magic. You just put the components in place, you put hot air on it, and everything melts in its correct position, and it looks good. It doesn't look butchered after you've. It almost looks original. So I like working on SMD. Now they don't have to be too tiny. If you have like a capacitor that is like the size of a grain of sand, yeah, okay, that's also a bit too much for me. But I don't mind working on SMD at the moment. Maybe if I get older, I will start hating it a bit more. But at the moment, my eyesight is still fine. So. Well, my eyesight is not fine. My glasses are still fine. Let's put it like that. Well, maybe, Timothy, maybe. I don't know. I also struggled with it before when I was just doing it manually. I also struggled with it. But yeah, if you ever need to do SMD work again, for some reason, I would really suggest using solder paste because it is it makes life much easier. These were 10, but I think these guys, they were still acceptable. Yes, 11. And that's the third one. 11 as well. Yes, so that is, yes, Casper, that is, you do, I think, run a risk of, if you're not careful with SMD, to making things worse. Because if you're soldering or if you're using hot air, it's very easy to just blow a component that you didn't mean to remove, to blow it off the board or to put the tip of your soldering iron against another component and accidentally desolder something. Yeah, I agree. It's not easy. I think a microscope can help. I don't have a microscope because I am, how do you say it in English? I am nearsighted, right? So my eyesight is close by, it's very good. So I don't really need a microscope, because I can imagine it can really help as well. Okay, so next ones. I think on this board here we have 4 left. I think there are 3 green ones over here and then the big guy. So I'm gonna leave the big guy for now. I'm gonna do these 3 green ones. And they are, I need to be careful because they are installed in different orientations. And these are 100 microfarad at 16. It's a new value. I haven't you had that one yet? 100 at 16. I have here. It's 110. This 116. Okay. My entire bench will be full of little containers with capacitors when I'm done here. Let's take the first one out. Should I? How am I going to do it like this? I'm knocking things over here on the bench. Okay, let's take that one out first. How is it oriented? These are the first 2 days are both oriented with the positive towards me. So let's take this one. Where is it? Which one? Wait, it's over there somewhere. I think it's that one. Yes. Let's measure this one. This is it's branded Towa. So it's again a different brand. 100 microfarad at 16. Let's have a look. No, that one is still good. That is perfect still. But since I'm here, I'm gonna swap it anyway. Yes, 116 and the positive was towards me, like this. Next one is the same. Let's test this one. Same thing. These are still fine, these green guys. 116 again. Oh, forgot to clean the... Yeah. I forgot to clean out the holes, the through holes. And then the next one, I think is also the C7, but it's oriented differently. It's oriented with the negative towards the top. So I'll have to watch out. I think it's the same. It's also 100 microfarad. Yeah, so I guess this one will also still be fine. Yep. Let's clean this one up as well. Okay. $116. Yep. And wait, this was negative towards the top, eh? Right? Yeah, negative towards the top. Okay. Okay, I think apart from this big one, I think we're done on this PCB. Yes, so yeah, let's do the big one. The big one is 330 microfarad at I don't know which voltage, because it is hidden around the corner. I think it will be quite a high voltage because it's a big cap. So let's see if we can get this one out. Oh, let's check the orientation first. The orientation is negative side towards the edge of the chassis. I think I will have to remove the solder first on this one, because I won't be able to wiggle that big guy out probably. So I'm just going to... It is difficult to maneuver this thing with the neckboard flapping about in the wind constantly. Wait, where was I here? Now this is going to be interesting. Oh yeah, that's coming out. That's not bad. And now the negative side might be a bit more difficult, because it's probably a ground plane. Or, well, not a ground plane. Probably it will take a bit more heat, probably. No, okay. Now the interesting thing about this big capacitor is the brand, because I think it's branded Hantarex, which is the manufacturer of the monitor itself. Let's see if I can get the solder out. Yeah, I know, Timothy, I have a Lazy Susan, but it's difficult. I don't really like working on something by turning it around constantly, because then it doesn't sit well. If you then need to work on it, you really need to have a Lazy Susan which takes a bit of effort to turn, because otherwise it's just loose on the bench. So yeah. I think it should be coming out. Oh yeah, it's falling out even. See, it's a 200 volt, 330 microfarad branded Hantarex. So that's the same brand as the monitor itself. See, here you have the logo stamped in the, or embossed in the chassis. I see it's the same logo. So yeah. Let's see what this one gives. 330 microfarad at 200 volts. That one is still perfectly fine, I guess. Yeah. Anyway, I'm gonna swap it anyway, because I'm here. I have the replacement ordered, so... Hi Ricardo, how are you doing? Let's clean up this the pads here a bit. I think most of the solder came out with the pump. And let's see where I have the replacement one, because I think I ordered only one, because these guys, well, that's such a weird value, like 330 at 200 volts, when I am ever gonna need one like that again, and they are not super cheap. So I have here a 330 at 200 volts, and it's also needs to be, it's a 105, yes, 105 as well. It's a Nippon Chemicon, so very good quality cap. Yeah, so this one is going in. The only problem is that probably the leads are going to be, well, I think it's acceptable. Yes, they are only slightly too narrow, but it's perfectly fine. Yes, it's a bit of a different patient indeed, yeah. So if you missed the backstory, this is the chassis of my arcade monitor. So I have two arcade machines. One is in well, extremely bad condition, so that one is basically out of order. This is the one from the machine that is still working fine, well, more or less. It worked fine, the monitor, if I ignored the fact that the image was too small and was, well, bent on the top side. And then when I tried to make the screen larger, I lost sync in the video signal, and yeah, just didn't work. So the chassis really needs to be recapped. At least maybe there are some issues on the chassis as well, I don't know, but I can't really judge that before I recapped it, because we already found some quite horrible capacitors in the ones that we removed. Some of these caps don't even register on the meter at all. So yeah, I really need to do a recap first, and then I can check if it is behaving now like it should, and if not, then it might need a repair. Now the thing is that it wasn't really interesting to make a video about this, because I just needed to do a recap. So I think, well, why not do it on a live stream? So as I said in the beginning of the stream, there are 3 PCBs. The neckboard, that's what we started with. There were only 2 caps on here, so these have been done. And then here you have 2 PCBs because there is a divider here in between. That's two separate PCBs. So this one, the left one on your screen, is now completely finished. And yeah, so we have done 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21 capacitors out of 33. So yeah, this might... What time is it? Oh, I still have a bit of time, so I might be able to finish this today. Now, I won't be able to test this, of course, on the live stream, because I cannot just go upstairs and quickly put this in my machine again. I will report back on the result in a post or in maybe a short video or something. Anyway, I'm going to grab something to drink, so I'm just going to do a quick break, and I'll be back in like 5 minutes or so. So yeah, see you in 5 minutes. Okay, I'm back. Just got something to drink, and let's see the second board now. The thing with this board is, the closer I get to the flyback transformer, the more dirty this board gets, which is normal, I guess. But yeah, I'm gonna have to get my hands dirty to replace these caps. First, here we have another one of those tiny ones. Those were the ones that were super bad. This one is a 2.2 microfarad at 63 volts. Am I reading that correctly? Or is it a 22? I think it's a 2.2. Now for this PCB, I should have a better drawing or schematic. Let me see, because I think there are less discrepancies between the different versions of this monitor. Wait, where is the... Yeah, here it is. So now I am talking about this PCB, and the tiny one is C66, yeah, is that one. And C66 is 2.2 microfarad at 63 volts. Yeah, correct. Indeed. Oh, I just minimized the PDF. Let's go back to this shot. Okay. And let's just remove it. Oh, let's see first how is it installed. I think the negative side is pointing down. Yeah, the negative side is pointing down. Okay. Where was it? Over there. Where is my solder pump? There. Okay. Okay. I'm having issues with my microphone today. It's always trying to creep behind my shirt, which is super annoying. Anyway, so this was a 2.2 at 63. I haven't had 2.2s yet, so let's see. 2.2 at 50, 2.2 at 100. That's the only things I have. So I'm gonna put a 2.2 at 100 in there. I don't have a lot of those anymore, so I should order new ones. And the positive side was up. So I'm gonna put this in like this. I think those are Panasonics, the one that I'm putting in. Yeah, I think so. And let's solder it in, and then we're gonna measure the one that came out, because I think that one is gonna be bad. It's also an ITT branded, and so far all the ITT caps that we took out of this, they were pretty bad. Or, well, not just pretty bad, they were extremely bad. Let's see. Oh. Two to 2 microfarad, right? Well, that's surprising. Okay, the ESR is, well, big. Well, 3 ohms for a 2.2 microfarad cap. I think that's still acceptable. But that's another one done. Next. There is a slightly bigger one over here next to this transformer that usually goes kaput on these monitors. It's a 4.7 at 250. 4.7 at 250. I must have ordered those because I cannot imagine that I have that just in stock. That's 47. I think there's going to be quite a lot of high voltage caps in this section because this is, well, the high voltage section. This is also not what I was looking for. That's no, that's not. Wait, what did I now just say? 4.7 at 250. 4.7. No, these are not. Here, 4.7 at 250. Okay. Yeah, I placed an order on DigiKey with the values that I didn't have in stock, so there's that. Now let's take this one out. Where is the negative side? It's towards the transformer. Okay. Is that leakage? I think so. See, that looks like corrosion. I think that's a leaky cap. Let's test it immediately. 4.7. It's just open. This is completely shot. See? Nippon Canicom. Well, Nippon Chemicon, 85 degrees, yeah. Totally shot. Okay. I think this cap might be the reason why this transformer dies on these machines, because one of the two windings of this transformer, it has extremely tiny wires, and they corrode. So they corrode, and when they start corroding they break, and this transformer goes open. And if you have a leaky cap sitting right next to the transformer, it's probably the reason. And you see this cap here is placed just next to this resistor, which is mounted like 1 centimeter above the PCB. So that one undoubtedly gets hot, and that just cooks this capacitor, I guess. So yeah, what was I doing? I was going to install a new one. 4.7 at 250. That, just double check. Yep. And the negative side next to the transformer. I still need to clean the through holes. So then, yeah, you see, it's really needed, huh? This recap. Sometimes really often I see people commenting. I'm part of a couple of Facebook groups, which are here in Belgium and in the Netherlands, for vintage audio materials and vintage repairs for electronics and things like this. And there are almost once a month there is a discussion on one of these groups, like should you recap things or not, or should you just only repair things, or what should you do. With this specimen you should really recap it. These machines, they had such a hard life, and these caps, they are in such a hot environment that there's no way that they're gonna survive this this age. Okay, that one is in. Then next up, there are again two of these green ones. So the previous green ones that we took out, they were still okay. These ones are 100 this one is 100 microfarad at 16 volt, and that one also 100 microfarad at 16 volt. And they are oriented differently, so I'm just going to do them one by one. And this one is very, very crooked. See, this guy. And it's the negative side towards the top. So let's take that one out first. (100 microfarad at 16). Where did I take it out? Ah, over there? Yeah, yes, over there. Okay. What was it? Wait, 100 microfarad, 16 volts, 100. Is this the 100 at 16 volt? Yeah. And negative side towards the top. Okay, let's measure this guy. I think this one is going to be fine. Unless it is also cooked because of the heat, but I don't see any big power resistor close by, so I think this one is going to be fine. Yeah, perfectly fine. I did a 1950s Marconi radio recently and it still worked with all original caps, but I still changed the algorithms in the Hans one since after 70 years you can't really... Yes, same thing. I did the video on the channel a while ago about that capacitor tester, and that one was from beginning of the 50s, I believe, and all the caps were still perfect. Was surprised, but I changed them out anyway. But yeah, in a position like this, if you put a capacitor next to a power resistor, it's gonna be bad. Doesn't matter the quality of the cap. It can be the most expensive cap that was ever produced or the cheapest one. Doesn't matter, it's going to be bad. So next, the negative, it's again the same 100 microfarad 16 volts. The negative is towards the left. And where is it located? I think it's over here. C23. Towards the left, right? Yeah, towards the left. So 100 microfarad at 16. That's again these guys. Yep. Okay. So then I assume that this one is also going to test okay. Yep. These green ones, they are surprisingly good, and they are branded Towa. Never heard of that brand, but they are surprisingly good. Okay. What else? I think there is another one like this. Yeah, there are two more. That one over there, that is also with, now this is going to be a bit more difficult to reach, because you see here in this area we have 1, 2, 3, 4, 5, 6 ones that we need to do. Let's take that one first. It's also same orientation with the negative to the left. So I'm going to see if I can, let's do the big ones first. I think then I can more easily reach, let's do this big guy first, because I probably swap those with a bit smaller caps, and then I can more easily reach those. So this big black one is a 2200 at 25 volts, and it's completely squished against the power resistor, so that's gonna be fun. And it's with the negative side towards the top, and I don't know which one it is. It's over here somewhere. I think it's this guy. Yes. It's C60. Wow, it's completely caked with soot from the heat of that resistor. That's amazing. I wonder how much that will read. Let's clean up the through holes. Okay. 2225 volts. Let's see what I have in my stock for 2200. I have 25. Perfect. I'm going to put that back because I don't think I will need any more 2200s. This is also a Rubicon, 25 volts, 2200. So negative side towards the top. And also because these newer capacitors are smaller, that also improves the airflow in this area, because they of course they block the airflow less than the old ones. Bum bum bum. That's installed correctly, I guess. Now let's put this one on the tester. I'm curious to see. So it's a 2200 at 25. Hello? Oh, I had bad contact, I think. Oh! Well, that I didn't expect. Nice. Just a bit bad contact here on the legs. It's flaky a bit, but yeah, surprising. Next, there are two more big ones. They are each 1000 at 35 volts, and the negative sides are pointing towards each other. So it's these two big ones. So let's take the first one out. And these are also these Toa branded caps. That's the first one. And let's measure. $1,000 at 35. Yeah, that one is going low. That is definitely out of spec. Well, yeah, I think it's out of spec. 1,000 at 35. 1,000. Let's see, 25, 35. So I am going to use, I could use Panasonic's, or I could use, what is this? I think this Nippon Chemicon. These are Panasonic's. Let's use the Panasonic's. They are a bit smaller. And they are all 105 degrees, so it doesn't really make a lot of difference. Let's take these two. Because I think the majority of the cap, no, the big one is also a brown cap, but the most of the caps I installed are black ones. So let's stick with that standard. And let's take out the other 1000 microfarad as well, and just need to keep in mind that they are pointing with the negative sides towards each other. So this one is pointing up with the negative side, and the other one is pointing down. Going to take that one out, and now I need to clean the through holes. Oh. Come on. It's 11 o'clock here in Belgium at the moment. So I said to myself I really want to stop the live stream before midnight. So but I think we will be able to recap the full thing before midnight. So that's nice. I honestly I didn't expect that I would be able to finish this, but it's going quite well, and the board is very easy to work on. It's very well built. The traces don't delaminate or the pads don't let go. It's really well built. We still need to test the other one, which was also 1000 microfarad. So let's see. Oh, that one is better. That one is a bit better. Now, let's put these two replacement guys in. Oh, there are the two tiny ones sitting behind. Hope I'll be able to reach those, because that's not gonna be easy. See those two guys? Maybe I should do those first and leave these 1000s for later. It's again an ITT that I see over there. The other one is so baked, or well, so covered in soot that I cannot read what it is. So let's take this ITT guy out first, and it is with the negative side pointing down. And where are the solder pads for this one? Because I think it's there. I think it's those ones. Yep. Okay. And this one is 2.2 at 63 volts. Okay. Yeah, my apologies for the camera work, but it's not, I only have one camera, so it's not easy to do a live stream with only one camera if you want to show stuff. So that's why I put it in this position. I hope it is still quite okay. So what did I say, 2.2, that's 50 volts. Wait, I had for the 2.2 at 63, I think I had 100 volts, right? Yeah. No, this is 4.7. Wait, what? 2.2 at 63. Oh no, I have 2.2 at 63 here. No, that's 2.2 at 100. Yeah, indeed, I was correct. Oh, it's getting late. And it was the negative facing down. Yeah, 2.2 at 100 with the negative facing down. Like that. Let's put that one on the meter. Don't have high hopes for this one, but we'll see. .6, yeah, so that's also not okay. That is 20% high, so that's also not fine. And before I solder this one in, I'm gonna take the other one out, and I don't see what it is or where the negative side is. I can't see it. I'm just gonna take it out, and I hope that I will be able to see where what the orientation should be when I take it out, because and otherwise we still have the drawing. It's coming out like this. I'm just going to keep the orientation like this, and yeah, it's the negative side pointing up. Okay, and it's a 10 microfarad at 25 volts, and it's a very weird cap. I mean, it's printed with gold lettering. It's like more coppery lettering on a black wrapper. It's very weird. 10 microfarad at 25. Where are my 10? Wait, where is my here, 10 at, this is 10 at 50. This is 10 at 35, but I don't like those, so I'm going to use the 10 at 50. And it was with the negative side pointing up. Yes, indeed, it's marked like that as well. I'm first going to clean the holes. It's very silent in the chat. Did everybody already go to bed, or maybe you guys fell asleep? It's also possible. I can imagine that the stream is very boring, but yeah, those are clean. Negative pointing up. Okay. I'm gonna solder these two guys in. Yeah. Yeah. You are having a very late dinner, Ricardo, even if it's only 10:15 over there. Well, I assume that you are also in the UK, right, Ricardo? Yeah, I think so, right? Now let's test this one, this weird guy with the copper printing, and it's labeled, I can't really read it, it's very bad print. No idea. No idea. 10 microfarad at 25. Oops. Yeah. Not too bad, but see the ESR is 2.5. It's they aren't great either. So there is now this one green one over there, which was again a 100 at 16 volt, and the negative was to the left. So now I'm also going to take that one out because I can reach it much more easily if I can find it. Is it this one? I think it's this guy. Yes. Negative to the left, okay, and that one is probably also going to be fine because that's again this green TOA cap. So the caps seem to be getting better the more that we take out. Oh, it's only, yeah, it's a 87, so that's also not great. Not dramatic, but not great. Now I did also spot some other repairs on this board. I think the output transistor, the how do you call it? The vertical output transistor, I think was swapped at some point. There were two big transistors here on the board that were are definitely not original. They were swapped at some point. So what did I say? 100 at 16. 100 at 16. I think these were the ones. Yep, 100 at 16. And the negative side to the left. Yep. And then I still have to put these two 1000 microfarad ones in that were facing towards each other. Like this. And then that one is going in like that. Okay. So and now just solder all these guys in. I think I'm making quite good progress here. Normally I do these kind of things, this kind of work, while I put on some music and I just because for me this is like it's almost a bit like meditation because it's a repetitive work. You only have to pay attention that you put in the right caps and in the right orientation, but for the rest it's not really very demanding work mentally. So I really enjoy doing these kind of tasks. But I thought, well, on the live stream they'll also be fun. Bum, 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 bum. Okay, those are in. Now what do we still have left? I count 4. There are 2 big ones over here, and then there are 2 little ones over there. I'm just gonna work my way down, so I'm going to do this one now, and these 2 guys, they are oriented with the negative side to the right, so that's the opposite of what we are used to, basically. Most caps, they are either with the negative to the left or up. This one is, these 2 guys, they are on the negative side to the right. And I cannot really read the values from this position, so I'm just going to take one out. I think they are both identical. Probably will also be quite high voltage, these caps. Yeah, and these ones are 47 at 250 volts. I think the other one will probably be the same. And I also had to order those in because I don't stock on 200 and 250 volt caps, because yeah, stocking up on low voltage caps is one thing, but stocking up on high voltage caps is a bit ridiculous because it gets expensive quite quickly. And well, what are the chances that you're gonna need a lot of those? The next one is all the way to the side. Oh, that one is difficult to reach. It's all the way here next to this, next to the shield. I think it's over here. Yeah, that's difficult. I'm lucky that I have very long fingers. It's also with the negative side to the right, and it's also 47 at 250. Yeah, they're both 47 at 250. Oh, come on. Yep. You know, I actually played piano. That's funny that you say that. I played the piano for 7 years. I think so. I played the piano from age 7 to age 14, I think. But then I quit because I was so sick of it. So, well, I really wasn't that good at it, and then it's not really a lot of fun. Plus, I followed piano lessons in a very classical school. Yeah, in the 90s, here in the neighborhood where I live, all the musical schools, they were still very classical, so there was really no wiggle room to do like popular music or things like that. So we only had to play Bach and Mozart and Beethoven and these kind of things. So that makes it quite difficult, and I was not really good at it, so I didn't enjoy it anymore at all, so I quit. When I was like 14. But when I was 14, I could span with one hand, I could span a full octave already. So from one note to the next, I could easily span with 8 keys with one hand when I was 14 years old. The teacher was always impressed with this, but that was literally the only thing that she was impressed with my playing, because my playing was really, really bad. Okay, so 47 microfarad at 250. Yeah, here we are. 47 at 250. I ordered. Well, let's test them first. Because I'm also curious about these ones. These are again ITT labeled caps. So let's see. Wow. Well, like I said, the caps are getting better and better. And the other one. A bit less, but still perfectly fine. Perfectly fine. $47 at 250. Yeah. And then let's try to wiggle these guys in place, because god damn it, this is a tight spot. Yeah. See, it is all the way over there. Yep. And this one is more easy. That just needs to go there. Okay. And then we have only 2 left, and I will be easily able to finish this before midnight, so I am happy. I don't know when I will be able to test it, because I have work tomorrow and I have quite a busy weekend ahead, so I don't know when I will be able to test it. Maybe Monday. Monday is a national holiday here in Belgium, so maybe Monday. Oh, that one. Okay, that one needs to go a bit deeper. If I can reach it, yeah. This is gonna be a challenge. I don't know how that guy came out again, but I think that's better. Now make sure that I don't have a cold solder joint here. It's a bit crooked, which I don't like. Yeah, that's better. Okay, 2 more to go. And the first one is again like this 100 microfarad guys that are always good, and it's with the negative pointing down. And it's sitting over there. And it's also a pain to reach because this heat sink is in the way and I can't see where there it is. Well, yeah, okay, I think I got it. Yep. Yeah. And indeed, negative pointing down. And these were the ones that were always fine, so I will put them on the tester, but they were fine usually. No, this one is not fine. This one is 25% low. $100 at 16 volts. Yep. And the negative side pointing down. And then we have one left, and that is this tiny little fella over here. It's C, what is it, 56? No, 65. And wait, what is the orientation of this one? Ah, negative side up. Okay, that's just the other way around as the previous one. And yeah, so this is, I think I'm gonna put it like this because it's really against the edge here. Oh, did my image go away? What happened? Okay. Oh, the image came back. What happened? No idea. The camera connection dropped. I don't know what happened. Anyway, hi Ger, how are you? Welcome in the chat. You are just in time to see the last capacitor being swapped, and that's this one over here. That's the only one we still need to do. And I'm gonna take it out. It's the negative side pointing upwards, so it's a tiny one, and I think this one will also be bad. The negative side pointing up, and it is an ITT branded 4.7 at 40 volts. Oh, these. What the hell? It's really dirty, the board here, so these pads, they are difficult to clean a bit because, yeah, okay, now it's working. So let's see again. Is that a 4.7 or a 47? I think it's a 4.7. Yes, it's a 4.7 at 40 volts. Let's put that one on the tester. Whoa, that is really good still. Okay. 4.7. I haven't used 4.7 yet. Weird. This is 4.7 at 50. Okay, that's fine. 4.7 at 40 volts with the negative side pointing up. So it needs to go like this. It sits a bit wobbly in this orientation because it now rests on the transistor, which is mounted against the side of the chassis here. Yeah, I don't think those are refas. I can double check. I don't think they are refas, but we can double check. I'm first going to mount this one in. Okay. I think that was the last electrolytic, and that was 33 in total normally. So here is everything that I swapped. I can put it in the screen here a bit. This is everything that I did, and I think about half of the caps were still acceptable, and the other half were bad or even completely shot. I think that we had a couple of those which were completely open, which didn't read at all on the meter. Some were shorted, so they read really like low capacitance. So it was really needed to do a full recap here. And yeah, they were a bit all over the place. Some were really good still, and some were super bad. There is only one thing I still need to do here, and that is I need to solder this wire here back in place. I guess it will come from here. Where would it else come from? Because that brown one is also going to... Yeah, you cannot see this. There is a big dropping resistor here, power resistor, and this wire, this broke off. So I need to strip that a bit, and then I need to resolder it. And then we can have a look at what you said about the refas, but I don't think there are refas on this thing. Oh wow, this is very crusty, this wire. Well, it's probably because it has been sitting against the heat of that resistor. I'm gonna snip a part off because this is never gonna work otherwise. Like that, okay. Wow, that's super crusty. I hope I can reach it. Yes, I can. Okay. There are caps on that small board. This one, the neck board. Yeah, there are two caps on there, two electrolytics, and we replaced them. That's the first thing I did. I started with this board. I replaced the two of them, and for the rest there are some resistors, lots of resistors on there, and this capacitor, but that's I guess a film cap, so that I don't think that needs to be done, and the rest are trim pots. So yeah, this is going to be difficult. Yeah, I think I need to clean up the this contact point of this power resistor here a bit, because oh, it fell fell down on the PCB and it soldered itself onto the fuse holder. What the hell? What the hell? Okay. Still a bit of a solder blob on that fuse holder, but yeah, it's not a problem. Okay, that's attached. So I think I'm done. So the caps that there is... No, I don't think it's a rifa, or what you call a rifa. Let me show you. It's the central heating unit, not... Ah, yeah, sorry, yeah. Probably, yes. I am really not that familiar with CRT electronics. I only know the very basics, so I don't... yeah, that was probably a mistake from my side. Here I can see those crystal-like metalized paper caps. Yeah, see, so this is probably the section that you were talking about. I think most of these are just film caps, like in the hundreds of nanofarad ones. So this blue one is 9100 picofarad at 2000 volts, and the other ones this is like 250 volts, 2000 volts, 630 volts. So these are all high voltage, low capacitance, I guess. I don't think there is anything that needs to be replaced in that section. Here you have where the fuses are, so I think more it's like the power supply section. Those caps, they are not labeled, those white ones. Ah, they are labeled here on the side. Maybe those are... this is a... and that's an X2, class X2 capacitor, 0.47 microfarad, 250 volts X2. And this one over here, I cannot read because the fuse holder is in the way. It's also an X2. It's similar, it's a bit fatter, so it's a 0.1 microfarad X2 capacitor. So those, well, are similar to Rifas, but they are not Rifa branded. So I don't think they need to be replaced. I could replace them. I think I have replacements for those in my stock, but I'm not sure it's needed. They aren't like the real Rifa branded things that blow up. No, I'm not gonna try and power it up tonight. It's almost midnight here in Belgium. I have to go to work tomorrow, and I don't want to rush things because, as I said, I am not that an expert on CRT stuff. So I really need to want to take my time, and I don't want to make any mistakes connecting this up and hooking everything back up correctly before trying it. So I really want to take my time for this. I'm not gonna do that still tonight. I might probably do it during the weekend. Maybe on Monday. Monday I might have some time. Yeah, thanks for joining, Timothy, and I also wish you a good night. Just to show you what other work has been done in the past on this thing, because it certainly has already been worked on. You can already see it over here. It's maybe not fantastic, but here on the high voltage cable for the 5-back, somebody hit it with the soldering iron. So yeah, that's not really the best thing to hit with your soldering iron, right? See? But I think it's still okay. It just barely, but it didn't penetrate the full isolation. So that's so that was my first sign to know that there was already been worked on. And then I started looking, what did they do? And then I noticed that they replaced, where is it? Here, these two transistors over here. So these two guys, they have been replaced. I don't know what they are doing. I haven't checked the service manual. It's TR5 and TR6. And I'm quite sure that they have been replaced. Yeah, I'm 100% sure because the soldering is quite sloppy. So TR5 and TR6, but as I said, I don't know a lot about how CRTs work. So let's see on the service manual. This is not the service manual. This is the service manual. So it's these two guys over here in the power supply section, just above this big capacitor, and I hope I have a schematic here somewhere. That's not possible that I don't have a schematic. Oh no. Huh? There is no schematic in this service manual, or in this scan at least. That's interesting. Ah, here it is. I must have skipped past TR5 and TR6. I guess we need to look in the power supply section. Oh, I zoomed in too far. Yeah, these here. So, yeah, those are regulators. Voltage regulators probably. Oops, sorry. TR5 and TR6. Ta-ta-ri-ta-ta. Yes, 160 volts DC. Here we have the rectifier. The rectifier, yes, those are voltage regulators, I guess. Yeah. Output voltage adjust. Yeah, so TR5 is one of the two that was replaced, and here you can see you can indeed adjust the output voltage. And then, okay. Yeah, so the power supply on this thing has been repaired at some point. But I think that's it. Usually, often you see output transistors or vertical output transistors go on these things, or also this little transformer here. But those are really the only interventions that I can see on this machine or on this chassis. So what I'm also going to do before I put it back, I'm not going to do that tonight anymore, but before I could put it back, I'm going to clean the pots, because I remember when I was trying to align the image, and that it was very, well, the pots were very dirty. Especially these ones on the board. I'm going to align or clean these pots, because yeah. Okay, I think I'm done here. I'm actually quite happy that I managed to do this today. I never thought I was going to finish this before midnight, but yeah, look, here we are. Let's see if I didn't miss any capacitors. No, I don't think so. Actually, this was this work that I did now was already on my to-do list for, and I kid you not, 15 years, really. I got this machine about 15 years ago, maybe longer, and at that time the image was already a bit crooked on the top of the image, and I already wanted to do a recap at that time, but at that time I was not really good in electronics yet, so I definitely didn't want to work on a CRT. So I kept postponing, and then I took my arcade machine, I put it into storage for 10 years. Now I got it out of storage again, and now finally I'm doing this. I already wanted to do this more than 10 years ago, so finally. You could also check with the parts list that those replaced transistors are the correct ones. Yeah, that is a good point. That is a good point, in fact. The ones that are in here are BF872 and BF871. Let's see. Yeah, it's the exact same ones. See, BF871 and BF872. So TR5 is BF872, yeah, and the other one is BF871. So they are correct, yeah. But they are definitely replaced because I minimized stuff here. Definitely replaced because one leg is like folded over to repair a part of the trace, and it's definitely not original. Now I hope that none of the wires came off here because of all the handling of these boards. So when before I put this back in the machine, I'm gonna clean the pots, and I'm gonna double check if I put all the capacitors in the correct orientation. And I'm gonna check if I didn't, if none of the wires came loose, and then I'll put it in probably on Monday or so. And TR9 are probably replaced too. TR9, wait, where is TR9? TR9. Ah, yeah, the one here on the side. Yeah, that one is mounted here on the side, probably. Yeah, that is also well, is that the one mounted here against the side? I guess it is, because it's not on the board here, so it should be the one that is mounted against the side. Now I cannot really see if that one has been replaced or not. I guess it might be. What is in there now? Oh, that is a BU326, and that doesn't seem original because it's a painted part. So yeah, that I think that's probably also replaced. Probably because it's in a socket, right? So it's difficult to see if it has been replaced or not, but I think it is replaced, yes. That's TR9 is probably, wait, which board is this? That's this one. Yeah, that's over there, TR9, yeah. Yeah, I think you're right, that's probably also replaced. Yeah, that's this one over here. Okay, it's almost midnight here, so I think I'm gonna close the stream. And yeah, I enjoyed this. I hope you enjoyed it as well. I would like to thank everyone for joining the stream and having a bit of a chat. I might do this again in the future if I have something that I want to work on, like recapping. Mainly recapping, basically, I think works well for a stream like this. So, yeah, I think that's it for me. So, I wish you all a good night. And yeah, I hope I'll see you soon in one of my videos or again on a live stream. So, yeah, take care. Bye-bye.